Welcome to today's ArXiv CS Digest for April 1st, 2026. We received 705 new computer science papers today across 54 subfields. Let's dive into top picks. Trend 1 of 5, Quantum Information Processing Fundamentals. Unifying fundamental principles of information, computation, and complex systems across quantum and classical applications. This cluster covers 99 papers. Representative work includes conditional channel entropy, sets fundamental limits on thermodynamic quantum information processing, quantum polymorphisms, and the complexity of quantum constraint satisfaction, and therefore I think. Trend 2 of 5, LLM agents and code generation. This trend unifies research on enhancing LLM agents and code generation through improved reasoning, control, and reliability. This cluster covers 160 papers. Representative work includes language steering for multilingual in-context learning, Cliff search, structured agentic coevolution over theory and code for scientific algorithm discovery, and LLM regression with a latent iterative state head. Trend 3 of 5, robotics, planning, and real-world AI. This trend advances AI, planning, and robotics for effective operation and prediction in complex, real-world scenarios. This cluster covers 158 papers. Representative work includes functional force-aware retargeting from virtual human demos to soft robot policies, latent phase inference from short-time sequences using shallow recurrent decoders, Lapis shred, and the recipe matters more than the kitchen, mathematical foundations of the AI weather prediction pipeline. Trend 4 of 5, benchmarking multimodal AI agents. This trend unifies research on evaluating and advancing AI agents that process and reason across diverse data modalities for complex tasks. This cluster covers 121 papers. Representative work includes Hippocamp, benchmarking contextual agents on personal computers, $\text, YC benchmarking AI agents for long-term planning and consistent execution, and assessing effective objectives for communicative visualizations. Trend 5 of 5, high-fidelity 3D vision and imaging. This trend explores advanced techniques for generating, understanding, and interacting with highly detailed 3D visual representations. This cluster covers 167 papers. Representative work includes universal YOCO for efficient depth scaling, trace, high-fidelity 3D scene editing via tangible reconstruction and geometry-aligned contextual video masking, and neural harmonic textures for high-quality primitive-based neural reconstruction. Up next, our first paper out of 5, Approximating the Quantum Value of an LCS Game, is RE Hard by Aviv Taller and Thomas Vidic. Let's break down its key contributions. The paper extends Hastad's long code test, originally for classical provers, to be applicable and robust against entangled provers. This generalization is crucial for quantum settings and foundational for further analysis. It demonstrates that the generalized long code test maintains its properties of completeness and soundness even when facing entangled provers. This ensures the test's validity and reliability in quantum interactive proof systems. By combining the generalized long code test with Dong et al.'s result on MIP *(re) with constant length answers, the paper establishes that align MIP *(re). This is a significant complexity class equivalence. Up next, our second paper out of 5, Jailbreaking Generative AI, Multivector Phishing Threats and Transformer-Based Defenses by Reena Mishra and Gaurav Varshney from Indian Institute of Technology, Jammu. Let's break down its key contributions. This foundational phase empirically analyzes jailbreaking vulnerabilities in ChatGPT for Omni. It demonstrates how novices can bypass safeguards to generate complete multi-vector phishing attacks across various channels, establishing the problem's severity. Controlled experiments reveal that specific role-based jailbreaks effectively produce fully operational attack paths. These methods enable the generation of credential harvesting campaigns across email, web, SMS, and voice channels. User studies quantify the disruptive potential of GenAI assistance on novice phishers. Participants showed significant increases in perceived competence, task completion rates, and reduced implementation time for phishing campaigns. A robust transformer-based detection framework was developed to counter malicious prompts. Utilizing XLNET, It achieves a high F1 score of 0.9864 for accurately identifying and classifying jailbreaking attempts, enhancing LLM security. The study provides a comprehensive annotated dataset of malicious prompts and their benign counterparts. This resource is crucial for training and evaluating future transformer-based defenses, supporting ongoing research in LLM security. Up next, our third paper out of 5, Learning Humanoid Navigation from Human Data by Weizhuo Wang and Monroe Kennedy III from Stanford University. Let's break down its key contributions. EgoNav employs a diffusion model to predict distributions of plausible future humanoid trajectories. Conditioned on past trajectory and environmental inputs, it learns navigation priors from human data, enabling robust path generation. A comprehensive 360-degree visual memory module is integrated, fusing color, depth, and semantic information. This provides a rich, multimodal understanding of the environment, crucial for informed trajectory prediction. Up next, our fourth paper out of 5, Deep Networks Favor Simple Data by Wei Liu and Yubei Chun from UC Davis, USA. Let's break down its key contributions. This paper introduces a novel framework that explicitly separates the pre-trained deep network from the density estimator. This allows for a more flexible and general analysis of density estimation across various model architectures and outputs. The paper proposes Jacobian-based estimators as one method to derive densities from network representations. This approach enables density analysis for models where traditional likelihoods are not directly available, broadening the scope of study. Autoregressive self-estimators are introduced as a second novel method for density estimation. These estimators leverage the network's internal mechanisms to assign densities, making the analysis applicable to a wider range of deep models. To quantify the observed ordering of sample complexities and estimated densities, the paper introduces Spearman rank correlation. This metric provides a robust, non-parametric way to measure the consistency of density assignments across models. Up next, our fifth paper out of 5, Thinking Wrong in Silence. Backdoor Attacks on Continuous Latent Reasoning by Swapnil Parekh from Intuit. Let's break down its key contributions. ThoughtSteer initiates the attack by subtly perturbing a single embedding vector at the input layer of the continuous latent reasoning model. This foundational step introduces the malicious signal into the model's processing pipeline. The model's inherent multi-pass reasoning mechanism then amplifies this initial perturbation, transforming it into a hijacked latent trajectory. This ensures the model reliably produces the attacker's chosen, incorrect answer. A key aspect of ThoughtSteer is its operation entirely within the continuous hidden states, producing no tokens. This design renders the attack structurally invisible and undetectable by all conventional token-level defenses.